Okay guys, so this is going to be our last note set over continuity. Okay, so this will be continuity example problem set number 2. Okay, so we're going to start by our 3 steps of continuity. Remember we said that f of a must exist, the limit as x approaches a must exist, and they have to equal each other for it to be continuous. Okay, so we're going to start off with our first step. F of 0 must exist. So we're going to be proving continuity at x is equal to 0, okay, because that's what's going on right here. Okay, so f of 0. 0 is defined in the bottom branch, so I'm going to plug in a 0. I get 0. Step 2, we're going to do the limit as x approaches 0 from both sides. Okay, the less than branch is always this branch right here, the left-hand side, okay? So the less than branch, I plug in a 0, I get 0, because 0 squared is 0. And if I plug it into the bottom branch, I also get a 0. That means the limit as x approaches 0 of f of x is equal to 0. Okay, I go into the third step. Third step says that if f of 0 is equal to the limit as x approaches 0 of f of x, therefore, it's going to be continuous at x is equal to 0. Okay? And there are times that this is defined, but they're not equal to each other. So make sure we pay attention to that. Okay? Now, when we go to graph this, let's do our t-charts. Make sure I'm saving some room for the next problem. X squared, and then x, we're gonna go x like that. Okay, so if I'm plugging in, so we're starting at 0, we're picking values less than 0. So plugging into x squared 0. Anything squared is always positive, guys. Make sure you remember that. Okay, and then if I'm plugging the line y equals x, I'm starting at 0, 1, 2, 3, 4. 0, 1, 2, 3, and 4. So this is going to be open in the top branch and it's going to be closed in the bottom branch. Like that. So this is a parabola. Okay, so it's going to look like a U. Okay, so we're going to start at the point 0, 0. It's going to be open for that branch 1, 1. 2, 4, 1, 2, 3, 4, and 3, 9 is up here. Okay, so it's going to look like that. Okay, now 0, 0 is closed right there, so I'm going to go ahead and color it in. And it's the line y equals x, so it goes 1, 1, 2, 2, 3, 3, 4, 4, and it's going to go on like that. Okay, so our graph looks something similar to that. And you can see that my fingers meet up, so the limit exists. There's no holes in the graph, so it's continuous. Okay, on the next one, we're going to prove the continuity at x is equal to a negative 2, and we're going to prove the continuity at x is equal to 4. Okay, so we're going to do, so we'll say 4, x is equal to a negative 2. So f of negative 2 is defined in this branch right here. So we're going to plug in negative 2 minus 1 is a negative 3. We're going to do the limit as x approaches negative 2 from the left-hand side and then the right-hand side. As I go from the left-hand side, this is the less than branch. Okay, so I already plugged in a negative 2, so I get a negative 3. If I plug in negative 2 in the right-hand branch, it's this one right here. So negative 2 times 2 is a negative 4, minus 1 is a negative 5. So the limit as x approaches negative 2 of f of x does not exist. Okay, therefore, not continuous at x is equal to a negative 2. Okay, now we're going to prove it at 4. Okay, so 4x is equal to 4. So f of 4. So f of 4 is defined in this middle branch. So 4 times 2 is 8 minus 1 is 7. Now we're going to do our limit as x approaches 4 from both sides. Okay, the less than branch is this branch right here, and I've already plugged in a 4, and I get a 7. From the right-hand branch, 4 times a negative 3 is a negative 12, and negative 12 plus 8 is a negative 4. Okay, so that means since the left-hand limit is not equal to the right-hand limit as x approaches 4, f of x does not exist. Okay. Now, as far as graphing this stuff, let's go through and let's do our t-charts for each one. So let's do x minus 1 right here. Let's do 2x minus 1 over here. And then let's do negative 3x plus 8 over here. Okay, so we're going to start at negative 2 on this one. We're going to pick values less than negative 2. So let's do negative 3, negative 4, and negative 5. We're going to pick values between negative 2 and 4. Negative 2, negative 1, 0, 1, 2, 3, and 4. Ran out of room. Okay, and then we're going to pick values greater than 4. So 4, 5, 6, 7, and 8. Okay, so if I'm plugging a negative 2 into the top branch, I get a negative 3. Negative 4. Whoa, wait, sorry. Yeah, negative 4. Negative 5. Negative 6. If I'm plugging a negative 2 into this branch, I get negative 3. Whoa, wait. No, negative 5. Sorry, negative 5. My mind's going ahead of me. Negative 3, negative 1, 1, 3, 5, and 7. Okay, and then if I'm plugging into this branch, 4 times a negative 3 is a negative 12 plus 8 is a negative 4. Negative 15 plus 8 is a negative 7. Negative 10, negative 13, and negative 16. Okay, so those points will be cut off the graph, but we can get an idea of what this looks like. Okay, so we're going to start here. Let's do our open and close stuff. So this is going to be closed. This is going to be open. At 4, it's going to be closed in this branch. And it's going to be open up here. Okay, open here, closed here. That's why we closed it down here. Okay, so let's go through and graph this. Negative 2, negative 3. It's going to be closed. Okay, so it looks like this. Okay, 2x minus 1. So we're going to start at negative 2, negative 5. 1, 2, 3, 4, 5. It's going to be open. And it's going to cross. So up 2 over 1, 2 over 1, up 2 over 1, up 2 over 1, 2 over 1. It's going to close right there. So it looks like that. And it's going to be closed at that point right there. And then we're going to go through and 4, negative 4. 1, 2, 3, 4 is going to be open. 1, 2, 3, 4. And we're going to go 1, 2, 1, 2. So it looks something like that. And as you can tell, there's going to be 2 breaks in the graph. The limit doesn't exist right here. Doesn't exist right there. That's called a jump discontinuity. Okay, guys, so this has been Proving Continuity Examples set number 2, and that should finish out the year for you guys. Hopefully you have a safe and healthy summer. To you seniors graduating, congratulations, and I wish you the best in all your endeavors in the future. Thanks, and have a good night.